Hi guys, Professor Dr. Tajur Rahman here. Welcome you all back to my YouTube channel Rahman Chemistry Coaching Academy. Today we are going to talk about the second example of conformational isomerism, that is propane. This is propane molecule with molecular formula C3H8, and these are the structure formulas of this propane molecule. The numbering to carbon atoms in propane molecule can be carried out from both right and left side, that is 1 2 3 or 1 2 3. Now look at to this three-dimensional arrangement of propane molecule. Although propane molecule is saturated hydrocarbon with sp3 hybridized carbon atoms, and the bond angle for sp3 hybridized carbon atoms are always 109.5 degree. But here, if we look at to this structure of propane, we can notice that the angle between C carbon atom is 112.4 degree, which is higher than 109.5 degree for sp3 hybridized carbon atoms. Similarly, the HCH bond angle is 106.1 degree, which is smaller than 109.5 degree for sp3 hybridized carbon atoms. The reason is that the repulsion between carbon-carbon atoms are more than carbon-hydrogen atoms. These are the Saha structures and Newman projections of propane molecule. In these projections, the front carbon, that is carbon number 2, is represented by a dot, and the rear carbon, that is carbon number 1, is represented by a circle. In Newman projections, we are viewing the molecule from front carbon, that is carbon number 2, this one. These are the ball and stick models of the staggered and eclipse conformations of propane molecule. Likewise, ethane, here in propane, again two extreme conformations are possible, that is staggered conformation and eclipse conformation. The barrier between these two extreme conformations of propane is slightly higher, that is 14.1 kilojoule per mole, than that was for ethane, which was 12.1 kilojoule per mole, and which we already discussed in our previous lecture on conformational analysis of ethane. This small energy difference in energy barrier is due to greater steric strain or van der Waals repulsion in propane as compared to ethane. In ethane, 3CH eclipsing can be observed on both front and rear carbon, while in propane 2CH and 1CH3 eclipsing can be observed on both front and rear carbon. Due to this, the steric strain or van der Waals repulsion in propane is greater than that in ethane, and hence the energy barrier to rotation in propane is 14.1 kilojoule per mole, greater than ethane, which is 12.1 kilojoule per mole. The potential energy graph versus bond rotation for propane is exactly the same as that for ethane, except that barrier of rotation is now 14.2 kilojoule per mole instead of 12.1 kilojoule per mole for ethane. This table shows the cost of energy for various interactions of alkane conformers. So this was all about conformational analysis of propane. Thank you for watching my video lecture. If you find my video interesting and informative, then please like, share, comment and subscribe my channel for more videos.